In this video, we are going to discuss about single slope ADC, analog to digital converter. So it consists of an integrator and comparator and AND gate, then up counter. So you will get a digital output. So consider my V reference signal is 5.4. Okay. So let me consider this V reference. This is a signal which I want to convert. So the single slope ADC is used whenever the time of conversion is not important, because it is taking a lot of time to convert from analog signal to digital signal. So let us discuss why it is so. So if you see Vx is my output of the integrator. So you know the formula for integrator. So Vx is equal to 1 divided by RC integration of 0 to t V reference dt. So this is my formula. Since I have a minus and minus here, these two get cancelled out. So you will get 1 divided by RC integration of 0 to t V reference dt. So this is my Vx. So if I consider my RC, if I multiply these two value, I will get the it is in terms of seconds, right? So RC value is equal to 1. Okay. So I can write this Vx is equal to 0 to t. V reference is like nothing but 5.4 dt. So if I solve, I will get 5.4 t. Okay. So next what I am going to do, I am going to compare this Vx with Va. If this Vx value is less than Va, I will get output as 1. Since this is plus value and this is minus value. So if Vx is greater than Va means I will get the output as 0. Okay. So if I take suppose if I take my V reference value is 4 volt. Okay. Okay. This is 5.4 volt, and I am going to take my analog signal Va is equal to 7 volt. Okay. I am going to take Va is equal to 7 volt. So you can see so till this one the output is 1, right? Because Va is 7 volt and Vx is nothing but 5.4 of t. So Va is greater than Vx. So I will get this is 1. So it will started to count up, right? So what will happen? So it will started to count up. So from 0 to it will started to count like this. Like, okay, since my input V reference, this is my V reference, right? So the V reference value is this is nothing but minus 5.4 volt. Okay, so the integrator will count like this, right? Vx up to t. So it will start to start to increase like this, and it will it will stop at one value, right? So it will stop at one value. That time is nothing but when Vx is equal to Va, right? So whenever the Vx is equal to Va, so that is this time, it will start to it stop to increase, right? So what is a Vx value? Vx value is nothing but 5.4 of t, and Va values I have taken it as 7 volt. So from this one I can calculate the t value. T value is 7 divided by 5.4. So at this time At this time, it will stop, and the Vx value is equal to Va. So that is my time. So if I solve this one, okay. So what is 7 divided by 5.4? 7 divided by 5.4 is 1.29 seconds. Okay. So let me assume initially the up, up counter value, initially it is in V such state. So this 0, 0, 0. Okay. So at 1 second it will go to 0, 0, 1. Right. At 1.29 second it will go to 0, 1, 0. Okay. So what is my output? So for 7 volt, okay, for 7 volt, the corresponding digital value is 0, 1, 0. Okay. So why? Because it is depending on the values of it is depends on the value of RC, right? So if RC instead of it is 1 second, if it is 2 seconds means the value get changed, right? So if, suppose if I take instead of 1 second, if I take it is 2 second means you will get this has to be divided by 2. So so therefore I will get um, time is twice this value. So this also get changed, right? So here the analog to digital conversion is based on the value of RC. So and you know that the RC value will change depends on the temperature on which it is working. So based on the temperature also it will get changed, and on the time of the conversion. So the time of the conversion. So for 7 seconds, it is taking 1.29 seconds. So for 5 seconds, it will take a minimum seconds, right? So the time of the conversion is depends on the input analog signal, right? So if it is 7 volt, it is taking 1.29 seconds. Suppose if it is 5 volt, it will take minimum second, right? Compared to 7 volt. So these are the drawbacks of the single stoped ADC. Okay, the drawback is it is due to the component values, that is R and C, and also due to the clock error. If there is some error in the clock also, um, it will not work properly. Okay, that's all about the video. Thank you.